Alright y'all, today we're going to continue talking about probability in order to make predictions. So I have two examples that I'm going to go over with you before you do your assignment, just to kind of refresh your memory. And we also have a new type of problem right here in example 2. So let's kind of think about what we've already talked about. So it says, when we're finding probability, remember we've talked about theoretical probability, so what that means is what should happen. Okay, so for example, if we have a bag of 40 jelly beans and there are 5 black jelly beans, if we're finding the probability, what is the theoretical probability of selecting a black jelly bean? We would say probability and put black in parentheses. So we're saying we're writing a fraction to represent how many outcomes we're looking for out of the total outcome. So right here, this is going to represent the black jelly beans compared to the total outcomes. And in case you forgot, the numerator is always going to be what we call the favorable outcomes. That's what we're looking for. So in this situation, we're looking for the favorable outcomes of black jelly beans. So if there are 5 black out of 40 total, we say 5 out of 40. So there's a 5 out of 40 chance for you to reach in and just get a black jelly bean. Okay? Now we could reduce that as well, but for right now we're just going to leave it as 5 over 40. Then I'll help you out in just a minute. So now we're going to make a prediction. So if we draw a jelly bean from the bag and we record your results, and we were to do this 80 times, how many times would you likely draw a black jelly bean? Now again, this is making a prediction. So this first original ratio is going to be our probability, and the second ratio is going to be my prediction. So we always start with our one table. The W stands for in words, so we're comparing black jelly beans to the total. And my original ratio, that's what that O stands for. Well, originally I had a 5 out of 40 chance of getting a black jelly bean. Now this prediction is if we were to do this 80 times. So if we had a total of 80 times that we were drawing, my unknown that I'm looking for is for that black. Okay? Now remember with ratios, 2 equivalent ratios is a proportion. That's what this is called, a proportion table. We can cross, multiply, and divide, so we could do 5 times 80 divided by 40. We could look for a scale factor, so 40 times 2 is 80, so my scale factor is 2. 5 times 2 is 10, so I have a prediction that x is 10. We can also look for a factor of changes, which we divide. So if we know both bottom numbers, that 40 and 80, 40 divided by 8 is 5, and 80 divided by 8 is 10. So there's a couple ways that we could do this. But if you just want to be consistent and say, okay, 5 times 80, and then divide by that other number, which is 40. So 5 times 8 is 40, and then put that 0 back, 400. So 80 times 5 is 400. And if we were to divide by 40, we would also get 10 if we did long division. Okay, so there's multiple ways that we could solve this. We could look for that scale factor or factor of change if we had it, but if not, cross, multiply, and divide works every time. So 400 divided by 40. 40 can't go into 4, goes into 40 once. Subtract, bring down, 40 goes into 0, 0 times. So, how many times would you likely draw a black jelly bean? We would say 10 times out of 80 you would draw a black jelly bean. Okay, so that's what that 10 represents. 10 black out of 80 total. Now, that doesn't mean you're going to get the black jelly bean 10 times out of 80. You could get it more, but in theory, that's what our prediction is. Okay, so let's look at a new type of example. So it says, Mr. Majuno put colored markers in a box, 5 green, 6 black, and 1 red. He will have students pick one and then record the color. Predict how many times you will choose a black or red if you conduct the experiment 36 times. So this one you've got to be really careful about, because think about our original ratio. So we're looking for first the probability of black or red. So we see that there are 6 black and 1 red. So when we look at that or in probability, that means we're actually going to add them together, because 6 are black and 1 is red, so that covers 7 of your numbers. So 7 favorable outcomes that are black or red. So that's going to be my numerator. So we're going to say black or red out of, well, if they don't give us the total, we have to find the total. So that's another thing you have to be careful of. They're not always going to tell you. Like this one told me that there was 40. This one doesn't tell me. So 6 plus 1 we already did was 7. The only other color was 5, those 5 green. So 8, 9, 10, 11, 12. So there's the 7 out of 12 total outcomes. Those are your markers. So that's my original ratio. Okay? So when we set up my one table, words, original ratio, new ratio. Okay? So we're saying black or red. Sorry, that kind of got pushed together. Black or red out of total. And we just figured out my original ratio right here. That's going to go where my original ratio is. There's 7 that are black or red out of a total 12. Okay? This is where some students get ahead of themselves. They say 6 plus 1, they remember to do that 7, and then they want to put over 36. But there were not 36 originally. There were 12 originally. This 36 is my new. If there's conducting the experiment 36 times, that's 36 total times that we're running that experiment. And it says how many times you would choose black or red. Okay? So be very careful with those labels. That's why we're showing you guys how to work with these proportion tables, because it really helps you see it. And project how many times you would choose black or red. That's your unknown. We're going to set those equal to each other. And here again, we could do 7 times 36 divided by 12. Or you might see, we know both numbers on the left. And from 12 to 36, we have a scale factor of times 3. So what I do to the bottom left to right, I do to the top left to right. So my answer would be 21. Okay? Again, you would not be wrong if you did 7 times 36 divided by 12. But if you can find that scale factor, it actually takes less time, because now I'm just multiplying one time. Okay? Alright, just to prove it to you, and make sure you get it, we cross-multiplied 7 times 36 divided by 12. We still get 21. Okay? But we're not using our calculators, we're using our math skills and writing it down. Alright guys, so hopefully this is helpful. So again, the key new phrase for you guys today is when you have probability and it says black or red, or if it were to say green or black, we're going to add those two numbers together for our favorable outcomes. Alright, good luck on your assignment, and let us know if you need help.